José Litown, que de Facebook iba a dar una charla, no está y no lo encontramos. Así que vamos a cambiar un poquito el orden de las cosas, a ver si mientras tanto aparece y podemos dar todas las charlas que teníamos previstas. Entonces, Íñigo se ha ofrecido voluntario para empezar el taller de Kibana ahora mismo. Como la sesión esta de la primera hora era un poco más corta, pues si no le da tiempo a acabar, lo que hacemos es cortar para el coffee break y seguir después. Y luego ya doy yo la charla de mediciones y esperemos que mientras tanto José le dé tiempo a llegar, a ver qué ha pasado.
A ver cómo el stream. ¿Me escucháis bien en el fondo? Just wondering, should I do the workshop in English or Spanish?
Se ve muy pequeño, procuro que sea un tipo de letra grande,
Vale.
aunque salga menos, porque si no...
So how many around here cannot speak any word in English? So there's Marty, yes. Right. Then let's just go with English for the sake of keeping everyone entertained. Okay, so please try to forget this for a second. I'm going to introduce a little bit the idea behind the workshop. It should not be a workshop that you're going to be following with your laptops. It's really simple. I would simply like to introduce the stack. So that'll be Elasticsearch, Logstash, and Kibana. It's very popular these days, so I guess that most people around here have heard of such stack. Never heard, to confirm. So how many people here have heard of Kibana or all right, and how many of you have tinkered with it or all right, so there's a fair bit of a very experienced audience. All right, then let's just go quickly for the components. So we have the Elke stack. It's the fancy name for 3 software components written and maintained by Elastic, the company behind Elasticsearch, the software. They provide a comprehensive suite to move data around from multiple sources to multiple outputs. The Elasticsearch behaves as the backend where we store the JSON formatted events. And then we have Kibana, which sits right on top of Elasticsearch. Does not hold any data, simply queries, translates our clicks and requests to actual queries to Elasticsearch, leveraging the internal query DSL that they have. And yeah, if the pipeline is properly configured, probably just by using Kibana, that's everything that you need to do. In this case, what we're going to be doing is scaling a few log files that have been contributed by unnamed anonymous ESNOG people. And then these logs are in plain text, which means that we need to extract certain fields or enforce a structure on those. And then we're going to be indexing them to Elasticsearch. And then we're going to be seeing the results with Kibana. The idea is that we have we will perform the same exercise of reading the source files, indexing them to Elasticsearch, and see the results in Kibana in 2 stages, because in the first one, what I would like to do is make a very basic parsing that's simply going to be extracting the timestamp of the log and then the major component of it, and then keep the rest of the payload of the log into a dedicated field. And then on the second iteration of it, we're going to be applying more advanced, if you will, regular expressions to try and extract fields like IP addresses or whatnot. So without further ado, I can just go to the laptop and begin with it. Please feel free to stop at any time. It's very much an ad hoc thing. So if you want to be paying closer attention to the regular expression or whatever you want, just raise your hand and then we take it from there. All right. So, I'm gonna need to do some cleanup that I was intending to do in the coffee break. Won't be possible, so I'll have to do it here. Can you see well from the back of the room? Or good enough, at least? Okay. So, right. The logs that we have, they live in my home directory here. I'm going to be making use of Tmax, the terminal multiplayer. I created a very quick playbook, Ansible playbook, to just so you follow with me. We have Ansible with a few files and templates as well that will get dynamically expanded. And then we also have the data itself, which I kind of randomized with Vim, so it's not really properly randomized, but still you get the idea. So this is what we have. These are fairly standard ESNOG logs. One line, unstructured output, certain structure to it. I'm sure you're all familiar with it. They're very similar to, they're similar to Cisco ones, slightly easier and more pleasant to work with, but nevertheless it's the same thing. And then we have these other logs, which are funkier. They come with what I consider unnecessary things, probably an artifact of the export of the logs. As you can see, they are multi-line logs. This is no problem for the log parsing, which means that with Logstash you can consume any logs that you would like, be that single-line logs, multi-line logs, or semi-structured logs that are already outputted in JSON. And with this, the configs that we have, wait a sec. I'm going to ensure that we have everything okay. Should be the case. This is a Debian VM, but you can do the same with CentOS 7 or whichever flavor you like best. The best recommended practice is to stick with the Oracle Java if you can. However, for the sake of the demo, I am using the OpenJDK. It'll do the job just fine. And the playbook's supposed to be not taking this much time, that's for a start. But this is what it's doing. Basically, adding the repo key, configuring the repo, installing the packages, using the with items feature of Ansible that will expand this list of packages and update them. We deploy the custom rock regular expressions. So maybe it's the first time that you hear about rock. Rock is the Logstash filter to apply, well, yes, to parse arbitrary text and structure it. So the regular expressions are based on this, slightly obscure, I think, regular expression engine on Iguruma. This one page here in GitHub's been really useful to me. I will happily share the link with you guys if you request it later on, no problem. And as anything's Logstash, you configure it like that in Ruby style syntax. So after deploying them to a directory that we have told Ansible to please make sure that it exists, we copy the files, both for Junos and Nokia. Then the playbook goes there and deploys the YAML config files for Kubernetes and Elasticsearch. The reason why I'm leaving Logstash out is because we're going to be doing that by hand so that we can do the 2 iterations of the data. and then the playbook will again make sure that the services are started. Of course, demo. Okay, so since it's a VM, probably there's some time-related issues which may affect TLS. At any rate, I don't think this is such a bad thing, since I was preparing this during breakfast a few minutes ago, so whatever was running should be still running. Simply wanted to show how the playbook goes and does everything. Probably I should have network in first place. Let's check that. Okay. All right. Well.
TCP is your friend.
Okay. Timber.
Use 8888.
Yeah, well, these are, of course.
Yes.
I think they propagated via the TCP. What was the other one? 4.4 and 2.2?
8844.
Sorry?
8844.
Oh, well, that I know. I mean, level 3s, any
Or
customer solver.
222.
No, 1-4.
1.4. What all of those?
Sí.
That is, no?
Estos en ese sí teníamos.
Ah, never mind. YOLO. Okay, that's something. So let's see. Okay, that looks better. In case you're not familiar with Ansible, what we just did is execute the playbook. Well, the Ansible is installed with the default package that's available in Debian testing. Simply configured the hosts file, which is the inventory for Ansible to learn which hosts it can manage. And we're running the we're choosing the local connection or the local transport.
Can I use bigger letter size
Yes, I can.
for the webcast?
Okay. You think it's okay like this?
Okay, we'll try.
Okay, well, doing my best. So yeah, there's that. So the playbook executed, nothing too exciting there. What we can do, so we go to this main tab that I have here. Since we are running the same logstash pipeline again, what I'm going to be doing is ensure that the file input plugin does not remember anything that's been doing before, so we're deleting this file. And the logstash YAML file, there's absolutely nothing out of the default config here. Most of the stuff happens in the conf directory. As you can see, we have the intermediate files that I have created. So currently, Logstash does not support multiple pipelines, which means that it runs as a block. You can split the config file into different files, and then Logstash will parse them and assemble them as one unique config file internally. I tend to split them for convenience, so that we can only touch the files that affect backend work. And I will remove these, and I should copy the basic ones to the config. So this is it. Yeah, the inputs chunk of the config. It's only using 2 file inputs, one per log source that we want. We're not doing any log expansion or anything like that. We're simply telling it to check for this file, and that'll be it. For the purpose of the demo, in order to have the data in there, we're going to be telling it to string from the beginning. We are tagging, labeling, or enhancing the data by specifying which log type this is going to be. And then the only peculiar thing about this is that the Nokia logs, since they are multi-line logs, we need to somehow instruct logstash to split the files accordingly. And then basically this is it's self-explanatory. These 2 options are somewhat it's not straightforward what they do in the beginning. There's only 4 combinations, so you'll make it work. The pattern here is using Perl-compatible regular expressions. That's what I feel comfortable with, so that's what I used. And then I'll go to the outputs, skipping the filters for now, because that's where I would like you guys to focus. That's where you're going to be spending most of your time. So outputs first. One single output, Elasticsearch output, where we are telling it which index, Elasticsearch index, we're going to be sending the logs to. Where does this Elasticsearch cluster live? In particular, well, this very host. The codec that we're going to be using, JSON for Elasticsearch, since it's expecting JSON. And then in Elasticsearch, I don't know how experienced you are with that. There's the concept of mapping. Mapping in Elasticsearch is a way of telling which shape the data has, as in, does this field contain an IP address, or is it just a literal? Do we want to analyze that field while we index it or not? So that can be handled via the index template that I have not configured this time. I like to do that by hand. I don't like software to put things. Let's just say that for the way that I work and the workflow that I am used to, I prefer to handle the templates separately and have separate processes that keep those updated. And then the type that we mentioned before, the UNOS and Nokia, will be expanded here. This bit here is super useful. I'm very fond of the dynamic interpolation of fields. Here it's not very exciting, it's very simple, but it can be very convenient in order to reduce the number of outputs that you have. In this case, we're using a simple, a literal for the index, but I want to show you how different index setting in Elasticsearch would work. So what I can do is, since I don't have the VPN, what I can do is do it here. So basically, what we could do is say that we want to split different logs to different indexes, which is something that it's bound to happen anyway, as Elasticsearch is going towards keeping one single type of log per index. This is not a problem because you can invoke multiple indexes when making queries. So the idea is that if you want to access different types of logs, you can simply perform the query over multiple indexes. At the end of the day, Elasticsearch only cares about shards. So the index is sort of a convenience for us humans. So if we were to do that, what we could do is use the same construct that we have here. Sorry for that, guys. This is not my Vim, so it's slightly... We could do this. What this does is, instead of having two outputs with hard-coded types, we can compress that to one single output. That's very useful. That's very useful because you can handle, well, as many types of logs as you want, as long as it sticks to the naming convention that you're using internally. At my work, what we're doing is basically department dash type, with the few exceptions of departments where we have multiple teams that require separate indexes, as it could be the case of RipeStat or Atlas. So how it looks there is, other than the if-else that precedes this output, just imagine that it sits here on top. With this one, Elasticsearch output, we're handling very much everything. We don't have to reconfigure. If we add a new log source, that'll get automatically picked up. So that's the beauty of the interpolation of fields. So remember that tip, guys. So far so good, simple inputs, simple outputs. On the filtering side, that's where you embed the logic to do all the processing. It's not the prettiest that I have worked with. I, for one, feel more comfortable with a different tool that does the same things that Logstash does, but in a more lightweight way. It also has a Lua sandbox that allows you to perform arbitrary data transformations in there, which I find extremely flexible, especially if you compare it with Rock, which gets the job done. Don't get me wrong; it's really nice. It's like a Swiss Army knife. It's just that it's not very sharp. It's okay. So with this logic, we're simply splitting the logs. If they are Junos types, then we will get these filters applied. For the sake of this demo, since we don't want to go too deep and too much detail, we simply have the grok filter and the date filter. The grok filter will pick each log line that the file input has read. It will apply the Junos _ base regular expression to it. I will show you in a minute how that looks. The grok regular expressions are probably the most useful thing of this workshop. So we'll cover those in a minute before we go to the hands-on exercise. So we will try to apply those regular expressions to the contents of the field message. Once an event makes it to the Logstash pipeline, it is no longer a plain text single file anymore. This means that the log gets decorated with other fields, and the actual log is transported in the message field. We have many other fields, we'll see them later on, but we can apply the match grok filter on any message that we want. Since we have a timestamp on the log, which does not necessarily correspond, well, let me rephrase that, will not correspond with the millisecond resolution timestamp of the Logstash field, what we need to do is use the date filter in order to populate this special field that Logstash have, the add timestamp. That's the one that gets used for the Kibana sorting of documents. Kibana can use other documents, but I find it really convenient to stick to what the ELK people tells you to, because that saves you a few clicks later on. So if we have the timestamp of the log extracted to a field called TS, and it has this structure here, please notice that the year is missing, and the time zone as well. We simply use these, I think these are Java date time conventions, so just use that. And then we explicitly state which is the time zone. We run our stuff on UTC because it's distributed globally, so that'll be it. And then the missing year will be provided by Logstash quite conveniently. We do a similar thing with the Nokia logs. However, they do have the time zone. So we simply specify that using the capital Z here. And what that will achieve is get this applied. So yeah, it's sort of a wall of text for you, I'm guessing. I'm gonna try to pick a few of these first, take them somewhere else, and make it bigger. Like so. So you don't really have to configure everything from scratch. The upside to using Rock is that you have this wealth of pre-configured macros or shorthands for the regular expressions, and you can simply pick them and mix them to achieve what you want. You have to be careful. Sometimes what these field names translate to are not quite what you expect. So as you iterate on your regular expressions, you will learn to pay more attention to this. It's sort of an acquired taste. And here, yeah, it's very simple. You specify the field name, and then this is the convention that we have for the rock filter, and then the field names that you can find from here. Once you have that, you can use that block to build different expressions. What I like to do, or what I've seen out there, is to first extract the higher level payload from the log, and then perform further transformations on the extracted fields. So in here we're using the Junos timestamp that we just covered. We are, with the semicolon here, we're telling it to store the extracted timestamp to a dedicated field called TS. While it's tempting to simply stick to spaces, I found, especially in the beginning of logs, very, well, how would I say that? I recommend that you use the space macro here that will translate to tabs, spaces, and many things. Sometimes the spaces are padded. So if your regular expression simply has one space, but that one log has two spaces, then you will not be able to extract that log. And it's one log among thousands. So you're not going to notice unless you're explicitly checking that. But again, it's similar to the dev, test, and prod. You're slowly polishing your regular expressions until you're happy with the result. And then you're going to see an abundance of the data macro here, which is basically the root alt dot star. That's quite convenient for the earlier stages. The tighter it is, the more likely it is to fail, of course, but that is what you want. You want to begin things with, at least that's how I like it. You begin your regular expression journey with data that will make sure that it's going to be picking up absolutely everything. And then, as you learn and analyze the output, then you'll see, okay, this field only requires alphanumeric fields and a dash. So perhaps instead of doing data, that's going to be catching more than you want or expect in some cases. You can use more tighter expressions. So maybe it would help if I can also put the simple log there. I didn't bother anonymizing this one IP address. After all, you can transfer the RAD.NET zone and then you'll see it there. So good. You can see more or less the mapping of this. So we have the timestamp that we first defined here, and then we apply here. The space, you see, there's two of those. So we tell it to use the space one or multiple times. The host name is will be this one. And then here, this is where the fun begins. So I'll go to the end and then cover the other part. The greedy data, it's like put everything that you can find on the log on the message field until the end. I don't care. And everything in between. So for this demo, instead of having multiple Junos underscore base regular expressions that would match the 3 types that I have, I've tried to compress everything in one. Later on in Kibana, we'll see that this is not doing everything that I wanted, but I did not fix that so that you can see which are the common errors that you're going to be, the common pitfalls. So here we are telling it to expect 0 or 1 at most slashes, because the Unos kernel log lines have the slash prepended. And then we use the data to capture whatever process that is, be that SSH or inetd or the kernel itself, accompanied with some optional process IDs with the brackets, which you need to expand, of course, because otherwise they will be character classes. This construct here of parentheses, question mark, and semicolon, I think, or colon, I'm not so sure now. Yeah, I always get those wrong, sorry. So that's a non-captured group that allows you to specify other fields that you are going to be capturing, but how many times is that going to be getting repeated? So since these are optional, the bracket and process ID is not always there. So you can make that optional. And similarly, sometimes you have the log level behind that, and then you also have a further function accompanied by a function line. So basically, this tries to capture all these cases here, SSD, that, or for example, like this one here, that's RPD and then the function name, EP listen accept with the function line. So with one single line, what I'm trying to do is cover all these cases. You can start smaller and, for example, create one that will capture this one. Only with simple and easy, you can match. Should that first match fail, you can tell logstash to perform a subsequent matching that will try and find this one, this structure, and then you can do it in another regular expression to try and capture this other one. So basically, after that, what we have is all the gist of the log here. This thing here is going to get stored in the message field, as we will hopefully see soon. So let me recap what I have done before coming here, because I don't want to. I should start clean, not from an intermediate state. So we cleaned the file input cache. The Kibana is again accessible with the port forwarding. This is Kibana, in case you're not familiar with it. I'm gonna be deleting these two index patterns to recreate them so that you see how those work. And then you have the very convenient DevTools console that provides auto-completion breaks to me. So it should have auto-completion, but it does not. So I found that I have combination of factors to reload it. But then, yeah, it works. So this is beyond the scope of the talk. I will be happy to discuss it, but then I don't want to get much into details here. Okay, I tried to delete a couple of indexes. They're not there, so fail. It's fine. I don't care about that now. So let's make sure that logstash is stopped, and then let's just start it. It's slightly slow since it has to create a JVM instance on the fly. Stopping pipeline, and then we're going to see a chunk of text there again. hopefully not signaling any errors. Okay, so that looks good. So after this, the expectation is to go back to Kibana and be able to find the logs, as we just saw. So, demos, god damn it. We don't have everything that we expected, I think. Okay, because I have to reconfigure more things. So let me quickly go through the whole thing again. Yes, basic. I believe that the regular expressions that I have here are using since we have two stages, this one is storing everything in the payload field, as you can see here, as opposed to the message field. So let's go with this one, okay? We uncomment it, and then what we should be able to do is to delete everything again, and then let me review the outputs, basic, okay, and then start it, and hope for the best. In hindsight, I should have probably renamed the index so that we at least had certain data inside Elasticsearch already for us to play with. And it is not doing anything at the moment. Totally unexpected, sorry guys. So let's go see why this could be. So far it looks like it indeed found the files. It is recording its offset in there. So if it found the inputs and it put them inside the pipeline, then we should go here, try and find that, apply the regular expression here, and then go to the outputs, which I did not mess with, but yet those are not showing up. Very unfortunate. There's one thing, in the beginning it's quite opaque, so it's not very easy to tell what is going on in there. In order to make that more easygoing, they have this extension that provides monitoring. I'll try to read the one that we have in production so that you have a feeling of how it looks like. And second? Yes, that's right. It's not endorsed or okay. Still, we've not found out what's wrong with it. It may be the refresh time, which I don't think it's the case because it's usually set to 1 second.
Anyway, it looks like the Kibana index has disappeared. I mean,
yeah,
the
I deleted both of them. Again, stupid mistake, because
no, but something else disappeared as well.
while I was connecting to the VPN, you mean, right now?
No, I mean in Elasticsearch.
Yes, so when getting this API endpoint, you get a command line friendly list of the indexes. Is that what you mean? That we had more indexes there before?
Yeah, I'm looking at mine. 1 second, I think.
Okay, well, let's try and see what's up with this thing. In the meanwhile, if you have any questions, I can try and multitask. Not so sure why this is going on.
I mean, it's complaining that something called .kibana does not exist. Yellow, open,
Yeah,
Kibana is
okay.
failing. Maybe
Okay.
you can restart Kibana and it will create it.
This is something else.
It's a theory.
In Elasticsearch, you have 3 states: red, yellow, and green.
Yeah.
Green is everything is alright, red is we have missing data, and yellow is we don't have properly replicated data. So in this case, since we've not tweaked the default configs,
Ah,
we have, I think it is 5 primary shards and 1 replica shard, which cannot coexist on the same box.
yeah, of course.
So there should be now 1 unallocated replica shard. If we add another node, then that shard will be moved to the other one, and then we will see a green index again.
All right, understood.
While I am happy to be useful for once, this is still not working. Very, very annoying. So I will make sure that we are in sync with everything, with the basic configs. The other experiments are also using the payload field, which okay, let's try something else. Was not this one that I wanted to edit. So. I'm gonna remove more things which we can add later on, just making sure. So we have the message field. That in the first incantation is payload. Which what we have here, unit base, is storing everything in payload. That looks good. Again, should work. Let's turn it on and off again, as usual. I don't know, let's just see. Sorry for that, guys. I do understand that it's making the whole workshop less useful. So let's have a look at the output. I don't see anything that can indicate any error here. And we have something. Okay. So, yeah, we now have the basic processing done. In order to be able to visualize it in Kibana, the first thing that we have to do is create the index pattern for it. So, go here, you create the index pattern. You can have multiple time-based fields. This one, however, is the one that will be associated with the time picker, the one that will be used for the sorting. Please remember to do this after you have put some actual documents in Elasticsearch. Otherwise, at least in the earlier version of Kibana, this is 5.3, I think, or 3.3, something like that. It was released a few days ago. On the other one, it'll get confused. So one way of completely avoiding the problem is to only create or update the field list after you have the data in there. If you have an index that's already working and you add new fields, there's one thing you cannot do in Elasticsearch, in a currently running and open index, which is change the field value for a given field name. So if we have field message, which is a string, we cannot change that to an integer or a numeric value. That's because of how internally the documents get analyzed and stored under Elasticsearch in Lucene. So keep that in mind. If you update that, then you will get the popularity counters reset in a cluster that's supposed to be assisting operations. I don't find this extremely important. It's a minor annoyance that you lose that. So when you come here, okay, I think that was cached from before. So let's just make sure that we start clean. And then, let's see, I don't have anything here. Okay, yes. So this how it looks like. So I'm gonna collapse this so that we have more space. This is when we have processed, since we removed the date filter, and this is something else that you guys have to pay attention to. Sometimes you get the data into Elasticsearch, but it's not ending up where you expect it to. So please make sure that the timestamp field, that remember is the one that we just called it on the index object that's getting used for the time picker. Please make sure that it's what you expect. Once you use the data, the date filter, what you can do is override the contents of the timestamp field, which gets dynamically generated by Logstash. And you can override the content of the timestamp field so that it gets presented in the timeline when it actually happened. This means that, while this sounds obvious, this is a very nice attribute to this kind of time-based curated logs, because this means that you can make your pipeline stateless. So if you have, in a more elaborate architecture where you have multiple components behind a load balancer, then I don't really care to which member of the backend each log ends up, since by the virtue of the properly set timestamp field, when we go to Kibana, they will show up just fine. So that's a nice property that you can leverage when going with larger, big architectures. And okay, we have this is the structure of Logstash with failure. So let's see if we can find another one that does not have that. This is how it looks on the multi-line one. There's a slight difference between how it gets presented in Kibana and how it's actually stored. If you're iterating your value expressions, please check that you see the JSON output, the raw documents stored in Elasticsearch. Otherwise, you can be missing these that get interpreted, but you do have to account for in your regular expressions. So for some reason, this did not work. It failed. You can tell by the tag. If you're applying a regular expression, a grok filter to any field in Logstash, if it fails, it will add this underscore grok parse failure to the tags field in Logstash event that you can use to, for example, trim certain fields. If you like to keep your raw data in the message field and then apply your regular expressions, what you can do is at the end of the pipeline, in the filter section, you check for the existence of the grok parse failure tag, and if it does not exist, This means that it's gone through all the grok filters and it's run properly. You have extracted all the fields that you would like. So maybe you don't want to be storing and wasting all those resources in storing the raw log, which is basically duplicate information. So by checking for the absence of this tag, what you can do is remove that field. Let's try and see again, because since I've been changing things on the fly when I really shouldn't have, maybe I've messed with something. Yes, I've messed with something, so I changed payload, and now we have it on the message, so I should probably put message there instead. Alright, yeah. Now I know what I did wrong. So let's reset all the things. On the one hand, it's a pity that I have not been able to reproduce the log processing that, well, pretty much like I was doing 1 hour ago when I was on my own and not in front of dozens of people. However, it's nice that you guys are seeing this failure, because in my experience at least, working with logs, it's a pain in the neck and it's a highly iterative process full of exceptions. So yeah, you're gonna see yourselves stuck on this very often, unless you are fortunate enough to control how you log things. If that is the case, then I would recommend that you do JSON logging directly. There are tools that make this easy. Just like this one, for example. If you have a Java application, which are commonplace, you can import this library here, and it will basically wrap your standard log and turn it into this. It's also supporting context and stack traces and exceptions. So you no longer have to be messing around with the multi-line parsing, which is quite error prone and everything. But yeah, we have to work with what we have, and you don't always have direct control of the logs. But if you do, please save yourselves copious amounts of work and just stick to JSON logging, because you simply have to import it. It'll explode if it's not properly formed, which in my case, after processing, I would say, millions of logs, like 5 billion logs already, or perhaps more, it's never produced well-formed JSON. So bookmark this one. So I expect this to have run. So we go back here, and then let's see if this one works. Nope. Did it do something? I don't know. Now this would be much nicer if I would have, sorry, there's another one. I was missing that one. Weird. Where are you using? God damn it, I made a mess. It should be indeed trying to apply the value expression on the payload field. Sorry for that, guys. I don't know why, it was much easier in my hotel.
Demo effect.
I don't know who thought it was a good idea that I did a demo. Right, venga va, a ver si probamos ahora. What I can be showing you on the meanwhile, at least to provide some value to this slot of the talk, show you the other regular expressions, the more elaborate ones. For example, this one here, I'm going to try to split it. Something like that, perhaps. So, if we finally manage to get this one applied, what we will end up with are dedicated Elasticsearch document fields with each notification code and the numeric version of it together with the name, as well as the remote IP address and the remote port used by this one here. In this case, I am recording the port, the source port of the TCP connection, but if it's actually not providing that much value, it's interesting to see the randomness in the source ports. It's not something that you may be willing to dedicate resources or on your cluster, so if you're not interested in it, you can just remove that one, simply reference the integer macro that'll get matched, but it will not get stored. So you can do that across all your regular expressions to only pick the few fields that you want. Because yet another advice that I have is to try and, again, it sounds obvious, but to try and start small. Naturally, we want to store everything and be able to analyze everything, but if you begin like that, what you're gonna be ending up with is basically a mess of a cluster with full of junk that you're not gonna be able to make any sense of, or yeah, it won't be useful. If you grow incrementally and you have your fields properly stored and analyzed as you want them, this allows you to, for example, with a couple of Elasticsearch queries, you can get a list of the peers that on any exchange are trying to establish sessions with you but are not configured on your end. If I have a router that's connected to any IX, with the default logging that we have, we get one single log line every time that any given peer is trying to establish a connection towards us, a BGP session. So since that leaves a log, what we can do is we can go and check for all the Elasticsearch documents that record such attempt, get the list of IP addresses, and then you can probably cross-check that with PeeringDB and get contact lists, and then contact them and tell them to please stop doing that, or you can configure the session depending on who those guys are. Stuff like debugging sessions that used to have MD5 shared secrets, but some guys left the company, we no longer know if the MD5 password is or it's not, so having that in Elasticsearch is quite convenient. If you manage to have it there. It is still failing for some. Time-wise, how are we doing? Okay, then can I ask you guys to go fetch your coffees, and I'll fix this, because not only I'm looking like an ass, you guys are not taking anything with you, and I would really like you guys to take something out the workshop. So I am learning way more than you guys. Thank you for your patience, and I'll see you in a few minutes. I'll try and fix this first.
¿Qué media hora?
Pues 30. Pues tienes 30 minutos, o sea que tranquilo. El coffee break donde siempre.
Tú sigues algo.
Okay, so we're back. Apologies for the earlier mess. I fixed it, and what you can see now is the working version of the earlier work that I tried to present. The events here in the middle are the ones that have had their timestamp field properly parsed by the date filter, and consequently they show up where they should be. So this means that you can retroactively index archived logs, and they will be visualized directly on the timeline. And then to the right-hand side, we have the whole lot of Nokia router logs that have not had their date parsed. So that is how, if you were not doing the parsing of the timestamp field when doing like a bulk import, then you would see a spike like this one. So sticking to the UNOS logs, this is the result after you grok them properly. To the left-hand side, you can see that there are a few new fields here that you can simply search on or aggregate on. So for example, there's this guy, IRTs, who has had his password accepted for SSH. There's what else? The notification logs are kind of nice. EB notification log, that is. So here, if I can draw your attention to...
Can you make it slightly bigger?
Yes. It's not going to look pretty though, but still. So from this message, what we're doing is we're extracting the relevant bits, the IP address, the source port that we're not dropping yet, and the BGP notification codes, subcodes, numeric versions, and names. So something useful is to filter for those that are not configured. So connection rejected. You click there, it'll go and filter everything out for you. And then what you can do is you expand document and you tell it to show you the remote address. So with this, there you go. These are randomized, so nothing interesting here. However, should this be real logs, you could get a list of these, and now you know who has your who has you configured as a neighbor, but you don't have them. So you can make okay, easier. This search that we have here, you can quickly save it, and then if you go to the visualization, you can create a visualization quite quickly. You can make a table, align it to the okay, yes, this is better. So you can do a terms aggregation of the remote address field, and you request it a total of 50, and there you go. It'll make you a chart with those that are trying to establish sessions with you. The same process you can do for any other log. Those that have the MD5 password is they provided an MD5 shared secret, but we were not expecting it, and similar things. Going back here pretty quickly, if we shotgun approach. So these are the ones that are not properly parsed. One thing I forgot to mention. Since you're going to be pretty much every device output logs, and they mean the same things. They're just using a different language to tell you that. So if you can have consistent names on your Elasticsearch documents, that's really convenient. Again, common sense, but sometimes we forget about that. So those are nice practices, and if you stick to them, then they allow you to build more with the stuff that you have inside Elasticsearch. So in a similar fashion, the multi-line Nokia logs that you can see here, they have had their like clear groups and the like is extracted. So yeah, from here on, the idea was that I will show you more use cases before. Now I cannot, but you get the idea. So you will have more fields that you can perform aggregations on, and you can, this is a good one, for example. Quickly go here. Type non-Junos, that should give Nokia's, and then we already have to, but doesn't save it. is the advanced filter that you see here, filter intermediate. You see that after you've done the initial processing of the log, then you have an if-else loop where I have crafted specific regular expressions for specific logs. So if you come here, how did I come up with this list? So, well, for one thing, you should write the regular expressions for the logs that you care most about, which may not be the ones that you see more often. Usually it's the other way around. The ones that you don't see that often are the ones that you really want to be on top of. So let's do this, and then again, term segregations of the logger field. Here, that, you click, and then delete that, you click again, leave this up. And so you have here like a nice aggregations of the Nokia, of the different Nokia log types. This is the structure of this one vendor, but having this overview, after you've done the initial processing, you can have an overview of how are logs distributed, which are their structure, how are they writing their logs, and how thoughtful they've been. And with this, you can choose whether you're doing I stuck with BGP messages. So since we have this in one field, then we can go back to the config, reference that, check for the content, and like this one, if they happen to be the same log, different address families, different codes, but same underlying regular expression, then you can group them together. And that's it. And yeah, I really wish that I could have given you guys more stuff, but to summarize this, because I'm already overflowing on the next session, I had a question during the break. With Logstash, you can create many different types of architectures depending on how much data you're going to be processing. My recommendation is to deploy log aggregators that later on send it somewhere that for further processing, where possible, use VIPs to separate actual servers doing the work behind one load balance IP address. There you can do it round robin, no need to keep any session. And also, if you have a lot of, if you plan on using this for good, then I do recommend to add one buffering layer between the producer and the consumer. This can be RouteMQ, for example. I work with that. If you're not working with a lot of data, that's just fine. It'll be a pain in the, it'll be hard to work with once you have a huge backlog of messages, around, I don't know, 10 million messages in a queue, and that's going to take forever. So it's really not an option if you have a lot of stuff. If you have a lot of stuff, I am very happy with Kafka and super fast. Just check that out. So if you would like to, if you have any questions about how you can deploy Logstash in your own infrastructure, feel free to ask me any questions, and I'll be happy to help you guys with possible alternatives. But the idea is that try to make it stateless, try to add a buffering layer so that you can make maintenance on the machines without having the error propagate anywhere else. Because remember that we're doing stateful TCP connections, so if something breaks, then that'll cascade, and you don't want that. So that was it. Thank you guys for giving me the opportunity of going on my first workshop, and I've learned a lot. I hope that you've taken something with you, and that's it. I'm giving it to Jose or you. Jose. Then Jose. Welcome, Jose.
So I'm going to present this in English, just to keep with the format. But I do speak Spanish, so if anybody has a question, just stop me, and I'll answer in Spanish. I'll answer in some sort of mix. So this is basically, I'm a little bit under the weather, so I apologize. I didn't sleep, so probably I'll make mistakes and I'll start mixing acronyms, and this is MPLS, so it's full of acronyms, so if I say something incoherent, I'm probably mixing things. So this is essentially an MPLS investigation, right? And this was essentially something that we did I did with Said last year. Said usually gives his presentation with me, but he's in California. So essentially what we're going to be talking about is going to be, a little bit about the Facebook scale and topology, just because I think that typically helps people understand, some of our problem domains and understand why the things we tend to talk about are important. Because if you have, if your domain is relatively small and you can know it by heart, then, making this troubleshooting seems obvious. If you have this all over the globe and it's, an unspecified number of devices, things become much trickier, right? But I'll try to go, and some basics about topology, I'll try to go fast over that. The actual investigation, how did the problem get fixed? What are some of the lessons learned? What's the takeaway that people can, learn from this, so you guys don't have to go through the exact same process? And Q&A, even though the Q&A part, like I said, if anybody wants to stop me or wants clarification, just raise your hand, and this is pretty informal, so we should be fine. So Facebook scale and topology. Let me see if that works. Yeah, that works. So this is recent as December of 2016. So the takeaway of this basically is, a lot of people, right? A lot of people that use the platform on a daily basis and on a monthly basis. And the most interesting metric, at least to me, is the fact that more than 85% of those people are essentially outside of the US and Canada, which typically, depending on especially in tech, like the focus tends to be very US-centric, and our problems tend to be global because 85% of the folks that use the platform are outside of the US, right, and Canada. So our problem with the network has, is represented in a very oversimplified way like this. Which essentially, you have traffic patterns. You have two traffic patterns, right? This is the system to human type of traffic patterns, so essentially like egress. And then you have the machine-to-machine traffic, which is the one that allows, all the magic of like, machine learning and things like Hadoop, which are super intensive on the network, right? And this is, part of what fuels like our desire to simplify everything as much as we can, because this just keeps growing. And if you apply the same approach that you were applying for the last, 2 years, 1 year, if you try to make that work in the next 2 or 3, that's really not going to happen, right? So, some topology, so you guys, when I actually explaining the thing with the 10 router or 12 router diagram, you follow along. Like our topology, at least on the backbone, this is like from clusters to all the way to the edge, in a very simplified way. We have clusters, which are essentially groupings of servers that, they have top of racks, and et cetera, et cetera. We have routers that we designate as DRs, which essentially are the way to get out of data centers, right? They're data center routers, so very complicated naming schemes. And then we have the actual backbone. These are essentially LSRs, right? So, all they do is like switch labels, very simple stuff, nothing super magical there. MPLS, BGP-free, etc. Then when we actually get to the edge, we have PRs, which again, very complicated naming scheme. Is peer routers, so actual devices that connect people to, connect the network to the outside. And then the internet, at least in a very high-level view, right? The protocols that make this happen, at least on the backbone, are very simple. It's essentially ISIS, BGP, RSVP, TE, mostly because of auto bandwidth, right? Because it gives you that flexibility. Like when we actually designed the backbone many moons ago, and SDN was still really not feasible, at least in the way that this could be done now, if we had to do it from zero. Our auto bandwidth solved the problem of having like managing demand, traffic, etc., etc. We essentially have 3 types of LSPs. We have essentially S, SF, and A. And SF are basically LSPs that have FRR enabled. S have the same priority and the same hold that S, but they do not have FRR enabled. And A is basically everything else, right? So, if you're on A, anything is more important than you, and you get bounced around all over the place. S and SF, like I said, have the same priority, so they're equally important. The only thing is that if your traffic goes through SF, you get FRR. And FRR is great, 50 millisecond recovery in theory, so like you shouldn't really not experience loss in case of failures. Well, that's the dream. That's what the brochure says, right? So, how we come to this magical investigation of ours, right? This is a graph that essentially shows, again, very stripped up values on things, because legal people tend to like for us to go with graphs that don't really say anything. But believe me, right? Like you can see that that's many hours, right? Like this is 4 a.m., 8 a.m. So let's say that at least that's 9 hours. here everything is great or everything is very small, right? And then, loss becomes gigantic. And this is a graph that shows, different LSP types. I'm trying to mix things. Different LSD types going to different places, right? And the interesting thing is that this, like this chunk here, like the main block, are SLSPs, right? And then like this trailing set of, this trailing set of loss is essentially loss that only happens on SFLSPs, which is exactly the opposite of how the network was designed to perform or how it should perform, right? Like the theory is like, at the end of an event, or when you have an event for whatever reason, like you have a fiber cut because the shark is eating, the fiber that connects Europe with the US, or one of the fibers that connect Europe with the US, so basically like terrestrial capacity go down or flap or whatever. The design is A should take the, A should take the brunt of it, and then SF should recover as fast as possible because things should be put in bypass, and life is great, right? This is obviously not the case, right? So immediately we went into, okay, what's happening, why is this happening, etc., etc. And a note that I haven't mentioned is the fact that our backbone is multi-vendor. Like most parts of our network are multi-vendor. So, the vendors that you all know and love, and our own things, and everything has, every role tends to have multiple options because redundancy, because it makes sense, because it allows us to reduce blast radius, risk, etc., etc., etc. So, we basically with our tooling, or the tooling was able to tell us, well, we were dropping everywhere, but like the tooling was able to say, you are dropping on this device and on this interface and on this LP. So with that information, we capture some of those packets, and we start now analyzing, why is the device actually dropping this, right? And when we do the investigation, we essentially find, well, let's look at MPLS, right? Let's, like basically what's happening is that LSRs are dropping packets because they don't know what to do with it, right? It's similar to the theory of IP. You get a packet that you don't know how to get to the destination, you drop it. Similar with MPLS. You get a packet with a label you don't know what to do, it gets dropped, right? So we were seeing that, we were, okay, so why don't you know how to get there, right? So like our early findings was essentially that they would have invalid MPLS labels, right? So what I said before, those were packets that were coming with labels that essentially the device that was receiving them didn't have any information about the label, so he didn't know what to do with it, right? So we said, okay, fantastic. This is happening. We don't necessarily understand why. Let's try to do some active probing and figure out, find one of those LSPs that's affected so we can drill down in a specific LSP and try to figure out why 1,000 or more are having this, right? So we started doing active probing, which is essentially, doing MPLS pings from the headends, try to figure out, okay, let's find an LSP that's actually affected so we can drill down. And, with this, we essentially found an LSP that had like consistent packet loss, right? And this allows to paint a picture, right? And this is a picture that we painted, right? Or at least the one that was used to explain this whole story. So this is a single LSP going from a PR, and the names are simplified because if it was our actual names, then I would spend more time pronouncing the names than doing anything else. But the roles are, what I described before, right? So you have PR, you have LSR devices, and then you have another PR. So this was traffic that was going between PRs, so between pods, right? And this was the path and the labels that were supposed to be used in each step. So figure out that this happened when there was an event between these two, right? So there was an event, there was a fiber cut, or a line carry reloaded, I don't remember. Let's say it was a fiber cut, explain the sharks. And, this was it's an LSP that uses FRR, so FRR gets triggered, we go into bypass. This was essentially the bypass path, right? So now, the interesting thing was that this was, like you saw from the first graph, this was many, many, many hours ago, right? Like, this is not how MPLS is supposed to work. And especially, it's not how FRR is supposed to work, right? You're supposed to, you have a failure, you go into bypass. While that's happening, the heading is like, depending on something I'm going to explain further, but, you have to figure out, according to the RFC 4090, you have to figure out who re-optimizes, right? Whether this is the PLR or whether this is the heading. You re-optimize and you take that traffic out of the bypass because the bypass is temporary and, you shouldn't be in bypass 9 hours after an issue, right? Unless you have many, or you have bigger problems than that, right? So, with this picture, yes, I'm not going to skip to that. With this picture, we basically now had, like the situation on the ground, at least at that point in time, which allows us to go back into our tooling to get information that allows us to debug this and then obviously involve the glorious vendors, right? And it's hilarious to like put the two heads of MPLS, so the different guys in the same code, so they scream at each other. It's great. Highly recommended. But there were many questions, right? The first question was, one, why did we have packet loss, right? Which we identified because, like the merge point was dropping, and it was dropping because it was getting a label it didn't know what to do with, right? So why is that happening, right? How did we end up with a label we don't know what to do with? And number two, how on earth are we still on the bypass LSP 9 hours later, right? So after, after many days of investigation and like lab and et cetera, this was essentially this came down to 3 different issues that, 4 different issues. One of them you really can't do anything about, and the other 3 actually contribute to this, right? So bug number 1, and this is what I was referring to before, is that basically in RFC 4090, which is the FRR RFC for RSVPT, you're basically told, well, like what you have there, right? On a failure event, a protected LSP has to be repaired by someone, right? And you typically have 2 modes of doing that. Global reverting mode, which is the responsibility lies on the headend. So headend is supposed to, depending on some sort of input, whether it's path errors or looking into the OSPF or SAS information to figure out, well, there's been an issue there, I need to repair it, or this goes to the PLR, right? The platforms that we use all have as default basically global reverting mode. So this is the responsibility of the head, right? So this issue is, or issue number 1 was that global reverting mode was broken on vendor 1. And this basically is a headend problem, right? This means that you are, you go into bypass because there's an issue and you get stuck there, right? And why were we stuck in that situation? And this is more of a generic vendor bug than an actual MPLS bug. But the interesting thing was, like, let's say that particular vendor, for every LSP you have as a headend, has a data structure, has a flag that, I could put the actual name of the thing, but you guys will figure out who it is. So I just basically renamed this to awesome flag, right? And the purpose of this, flag is to indicate that the current path might be used by a bypass LSP. So let's say that when you are under normal operation, this flag is true. It doesn't matter what it is, but let's say that flag is true, right? So the event happens, right? The linker reloads, the shard hits the cable, whatever it is, right? Now this device is sending path errors back to the headend because of, global reverting mode, so you need to re-optimize on the headend, so the headend needs some sort of input, in this case path errors, blah, blah, blah. When that happens, the flag gets switched, right? So because that's a protection mechanism that they use, so you don't, put traffic into something that was already serving as a bypass. CSPF runs because you are supposed to, I put you on bypass, and then I'm trying to figure out what's the next best path to put you on. And then you do make before break, right? What happened in this particular scenario is that there was a race condition, right? So the theory is that you needed to not set that flag until make before break was done. And they basically weren't doing that, right? So they would never, like when they did the calculation, any other path would be discarded because it would say, like, I can't use any other path except the one I'm on because all of the other ones are not because of the flag, right? So, fix number 1 was fix the race condition, which is relatively simple, right? Don't set the flag until the make before break switchover is done, right? So that will explain why we were stuck in the bypass path for 9 hours, right? So number 2 is, okay, even if we're stuck in the bypass for 9 hours, which is, obviously suboptimal and not what's supposed to happen, why do we have loss, right? And this is a more interesting and more MPLS related bug, or bugs, right? Which is, basically there's an in-flight label change, which is the bug which is a situation that we can't really do anything about, right? Because this can be an issue with like RSVP sessions or, or device state or whatever that basically forces a device in the path to like do an in-flight label change. And basically what we were seeing was that the merge point change was not being honored by the PLR, right? So this dude was changing, or someone up here was changing the label, and then this change was not being honored by the PLR, right? So in this situation, when you're basically in bypass, you have 2 labels, right? At least when you use next hop protection, right? You have the actual transport label, right? Which is this one, which is the one that, basically this guy didn't know what to do with. And then you have the actual bypass label, right? So then you have multiple situations here, which is depending on the actual RFC tells you how you are supposed to infer the merge point label, right? Based on the RRO. But it tells you that, or it specifies that, for essentially the main LSP, right? It doesn't really specify how you do this on the bypass LSP, which meant that vendor one had one way of doing this, right? And it was one of the vendors that basically needed this to be specified as a sub-object on the RRO, and the other one would basically look at the RRO and figure out, something that belonged to the MP and extrapolate what should be the label for that, right? So essentially that incompatibility, plus the fact that you were stuck in a FRR for 9 hours, contributed to those two things, right? If you're doing a bug number one, this would have meant that you would have some sort of failure. The failure would happen. You would have loss when you were in bypass, but when you recalculate it, this loss will disappear, and it will be one of those things where, the network's being special, right? But because you were hitting those two things, right, which is like you were getting stuck in a state where you were having loss, is that we can actually see this, right? So the bug fixes, well, I should actually, I have arrows and things that help explain this, right? So this is, the labels change in flight, the drops are happening in the merge point. The PLR is using the stealth merge point label, which like I said, but here it's probably a lot more clear, is this one that we were using before, because basically the PLR had no way, or basically they had an incompatibility on how they would actually extract that information, right? So basically here, what we did was get both vendors to play along regardless of if the other was patched or wasn't patched, right? So vendor number one, basically what I said, right? Like they expected this, the only way that they could do this is if they had that sub-object in their RO, so we got, add that to your thing, right? And the other one is basically to extrapolate it if you need to, right? So that would allow us, because, if we only did one, then as we roll this out on the network, we will still have loss, because we would need to have basically a perfect state where everything was patched at the same time, and it's a lot of devices, so this wasn't feasible, right? So we basically needed something that, as long as we are deploying fixes, we would see reduced impact, right? Because with the amount of events that we have, we were hitting that every other day. Yes. So, questions, doubts, need to switch to Spanish? No? Great. You guys are very smart. It took me days to understand what was happening. Lessons learned. Well, this is probably no surprise to anyone, right? But multi-vendor is hard, right? In fact, as we're talking about now, this is something that happened, or this is something that, occurred over maybe May, June of last year. And even very recently, as of 3 weeks ago, we are now hitting another very soon. It's not related to a 4R, but it's along the same lines, because we are hitting a timing issue, because now we're testing a platform that's much faster than the platforms that we have. So basically, the other platform is so fast that it's actually revealing issues in the ones that have been there for years, right? Which is great. It's revealing issues with that the processes are not fast enough in the other routers to keep up with the label exchange. And then we have that type of issue where hey, I'm getting, for example, now we have an issue where, as the LSP is being set up, it gets a label, right, for downstream. It gets another label while the LSP is being set up, and basically it's completely ignoring that label and going I am not listening to you, and now it's programming the first one, which is no longer valid, and, packet loss, great. So multi-vendor is hard. Our testing on critical features, we have been on this trend of improving our testing and doing in-house testing and validation and all this stuff while trying to keep up with the speed that we need things to evolve at. Because most of the time we, in our particular scenario, are chasing the latest release. It's not because the latest release is great and I love living in the edge. It's because you need a particular feature, or most likely you need to be able to run code that supports the line card that has the biggest density that you need, right? And the only way of doing that is going to, the release that was released yesterday, right? So we basically have done a lot to try to improve that story, because even with the complexity of doing multi-vendor, some of these issues even happen when you have a single vendor, right? This situation that I'm describing that's recent doesn't necessarily, if you had a single vendor, you have decided I'm not going to be this, play along story, I will just, buy from company A and, live with company A for the rest of my life, and, the account managers will dance and be happy, right? You will still be open to, for example, the issue I just described. This issue that I'm describing now is not really related to, compatibility. It's related to the fact that now you have an ASIC that basically performs the same operation 15 times faster than the last two generations. So that already reveals issues, right? So if you're not if you don't have this process to ensure that what you're putting in the network widely is not going to melt, then you're going to run into problems anyway, right? So we added a lot of layers of testing. We have automated testing with canaries, better monitoring. Like we improve our MPLS monitoring quite a bit. But that's a generic thing, right? Like the other interesting thing was that failure doesn't necessarily equal impact, right? Sorry. And this is that we actually saw that event. Obviously not as bad as the 9-hour thing, but we saw like blips over time, and we were we would think like, well, this is because we lost X amount of T's of traffic, so that's a lot of that's a lot of traffic, or that's a lot of capacity to lose. So like there's going to be a lot of MPLS churn. And as our active probing got better, and we got more confident that the active probing was actually valuable, right? That every time it would say like, you have a problem, it was actually a problem, and it wasn't like a false positive or anything like that. We started investigating more, and the more you drill down into these things, we have now seen, before we put this magical platform that's like flash, right? The flash of networking. Like we would have the same fiber cuts, and now they would be, they would produce, 1/5 of the impact, right? Because we address the core underlying issues, right? So like there's definitely, there's definitely a moment where you need to do reality checks versus like, oh, well, I expect the network to perform this way versus is it actually performing that way, right? And this is something that, we always, I have the conversation with people, or even with when we hire new people, or, which is like, for example, there's like issues that our industry really hasn't addressed, or hasn't addressed properly, which is like my favorite one, which is the story of Pacalos. Like I think outside of like a very select group of people, like people think that Pacalos is a myth, right? Or, it's like this thing that doesn't happen, it's this thing that only happens to the web companies, and it's like, pick your favorite service provider, and if I'm dropping in my MPs with all the monitoring around it, you're dropping, right? You just don't know it. Because like interestingly enough, for example, this story that's evolving with like the super recent, this is 15 times faster than any platform known to man, is essentially revealing an issue that, as far as the vendor can tell me, has been in that code for at least 2 years, right? And this is not like a super sexy, fiber channel over Ethernet, bullet magic with voice over IP. This is core MPLS stuff, right? This is like LSP initialization, T with RSVP process talking to each other, and this is essentially something that, for that particular problem, which is a very well known, and all of you will know it and probably touch it, that, at a global scale has been failing at life for 2 years, and apparently I am the first one to report it, so, you're welcome. So, this is things that we need to address more, right? Which ties with point number 3, which is collect all the things, which is, for example, most people that I talk about, especially with large MPLS networks or small MPLS networks, when you have things that, auto-do stuff, right, like the auto bandwidth of the world, like most people don't have effective ways of monitoring that, right? Most people don't have, like if you go into a large operator that, that uses MPLS and you start like talking to them about like, like how often do you tweak minimum bandwidth, or like how are you ensuring that your number of LSPs is sane, or like, then you get all these weird answers that are based on like feelings and not really data, or you're getting, there's not a very good visibility. The more things happen automatically, the less, and the more this disappears from like an actual system, right? And this would have helped, right? Like for example, putting together that diagram a year ago took a significant amount of time, or it took a significant amount of debugging that's not normal, right? Like now it's a lot faster because we built automation around it, so like we can map all the story out. In fact, now we have active probing. So I don't know if it's it's like my mind goes with the slides script, which is monitoring end to end. Like now we are doing, or we were doing it since last year, like the synthetic traffic that we're generating. Synthetic traffic. We were always generating synthetic traffic between like endpoints between servers. We have things like NFI, which like triangulate between things. But we're also like trying to add this on top of MPLS, right? And we are, for example, the same thing that we did during the troubleshooting, it's happening automatically. So there's a tool that basically will go and it will ping all the LSPs every 4 minutes or something like that. And if the LSP has lost, then it will go and recheck it. And then it will go and isolate the particular LSP. It will grab some information, like you will try to clear the LSP, it will try to re-optimize the LSP to see if this is bull magic. If it cannot do it, then it will get a human involved with like all the information that it collected. So it makes it much nicer to say, instead of like, oh, there's loss, or the graph that I showed before, like, well, this LSP has problems, right? And then we can, and this is like, all the RO information and go look at this and this and this, and it's like, oh, this is great, right? But this is needed because at the end of the day, if you're running a global MPLS network, like this is the complexity that you chose to have by deploying that technology, right? And if that technology is not doing what you need and you cannot be sure that it's performing as you decided, then we're obviously not doing our jobs. And yeah, that's all. Thank you very much.
¿Preguntas? ¿Questions?
Jokes?
Bueno, esta la voy a hacer en español porque como esto es el ESNOG, por lo menos que haya una charla en español hoy día. Además, yo creo que Marty y Costas ya... You've heard this from Jeff Houston, so I'll do this in Spanish for the people who haven't heard it. Bueno, pues desde hace un año y un poquito más estoy trabajando con la gente de APNIC, que es como el RIPE NCC, pero para la zona de Asia-Pacífico, aunque sigo viviendo en España, es un poco extraño, pero se ve que toda la internet al fin y al cabo sí que sirve para algo. Y estoy trabajando en sistemas de medida de la red, ver qué están haciendo, qué está pasando en la red realmente. Entonces, os quiero contar un poquito de qué hacemos y cómo lo hacemos. Vamos a ir por los distintos pasos. El problema que teníamos es que queríamos saber un poquito cómo se estaba comportando la red, cómo se estaban desarrollando e implementando tecnologías nuevas en la internet, pero intentar medirlo desde el punto de vista de los usuarios, en lugar de muchos de los estudios que hay ahí que miran cómo se comporta la red misma, y a los usuarios se supone que siguen lo que hace la red, pero no siempre es así. Y queríamos hacerlo de manera que se pudiera obtener un resultado general para la internet, pero también con detalles a nivel de zonas específicas. En los sistemas de medición que vemos por ahí generalmente, hay sistemas que miden lo que pasa de forma pasiva, capturan el tráfico y luego hacen análisis. El problema que esto que tienes es que sueles capturar un montón de datos y luego tienes que ir pescando los poquitos de información que tienes en las redes. Entonces no es la forma más efectiva. A veces es la única que puedes hacer, pero bueno. Si lo haces introduciendo proxies, eso tiene sus problemas de privacidad, interferencia con el tráfico y todo eso. Luego hay gente que mide de forma activa, por ejemplo las ondas Atlas, que es un buen sistema, que generan su propio tráfico entre puntos de origen y destino conocidos, con lo cual tienes el experimento controlado bastante. Lo que pasa es que la gente cuando pone una sonda Atlas, como sabe que los resultados van a estar en las webs públicas, ¿qué hace? Poner la sonda Atlas en el mejor sitio que tenga en su red para que los números salgan lo mejor posible. Y en ningún caso vas a poner una sonda Atlas, a no ser que sea el usuario final el que la ponga en su casa, digamos, vas a poner una sonda Atlas, sobre todo un anchor, en un sitio donde estén los usuarios finales. Entonces, ¿qué hacemos? Para medir exactamente qué es lo que está sufriendo o disfrutando el usuario cuando navega, habría que conseguir que el usuario hiciera algo por ti. La cuestión es cómo haces esto sin pedirle que instale software, porque si haces eso, tu muestreo se reduce muchísimo, sin violar la privacidad del usuario y sin meterle problemas. De hecho, alguna vez hemos metido a algún usuario en problemas sin querer, lo hemos intentado corregir cuanto antes, pero a veces lo haces sin... Hay consecuencias que no puedes evitar. Pero intentas, por ejemplo, que no mandar al usuario a acceder a webs que puedan a lo mejor estar restringidas en su red y que vayan a lanzar una alarma de accesos indebidos y tipo de esas cosas, ¿no? O sea, ¿cómo hacer algo que cómo hacer que los usuarios hagan algo por ti sin molestarles? La solución que hemos optado por utilizar es recurrir a utilizar anuncios de los anuncios estos que Google presenta a todo el mundo, ¿no? Google tiene la plataforma que más o menos todos nosotros acabamos tocando de una manera, o directa o indirecta, cuando navegamos por la red, porque o usas el servicio directamente o cualquier web a la que navegues te va a enseñar anuncios presentados por Google. Es como ellos ganan su dinero, con lo cual tienen el mayor interés del mundo en que si tú les das un anuncio para que se lo presenten a los usuarios, lo van a presentar, por lo menos hasta gastar todo el dinero que les has ofrecido que pueden gastar por ti. Y luego tienen varias categorías de anuncios. Una de las categorías de anuncios que tienen, que llaman ellos los image ads, te presentan no la típica línea de texto como cuando haces una búsqueda, sino que te presentan una imagen. Y esos tipos de anuncios pueden tener tres componentes. Uno es la imagen, como por ejemplo el logotipo de Aperic. Un texto que tú puedes poner para vender el servicio, por ejemplo aquí. Y algo que no ves, que es un snippet de JavaScript. ¿Vale? Que el navegador se lo baja y lo ejecuta automáticamente al presentar el anuncio. Cuando haces eso no tienes que pasar un proceso de autorización por parte de Google, como si fuera un App Store, una cosa así, para que ellos verifiquen que no vas a meter al usuario en líos. Pero por lo demás te dejan hacer que el browser del usuario haga todo lo que tú le digas. Entonces, bueno, pues optamos por utilizar esta plataforma como forma de hacer correr software en el equipo del usuario final, que además está muy bien porque vale para plataformas móviles o para desktops sin que tengas que hacer nada más. Está todo basado en JavaScript, el HTML5 incluye el JavaScript y es una parte obligatoria, o sea que todo el mundo ya tiene plataformas que usan HTML5 en estos momentos. Es verdad que el browser limita un poquito lo que puedes hacer, no puedes intentar acceder a la máquina, no puedes... básicamente puedes hacer peticiones de HTTP, pero puedes hacer gets, puedes hacer puts, puedes hacer posts, puedes hacer bastantes cosas. Entonces, ¿cómo combinamos esta idea de tener el JavaScript haciendo peticiones, dentro de las peticiones que te permiten hacer, corriendo en el browser, con forzarle a que haga cosas especiales para poder pedir lo que quieres y sin molestar al usuario? Los gets que nosotros hacemos, que el JavaScript va a hacer para nosotros, que van a ser las pruebas de si el usuario puede llevar a cabo tal tipo de actividad o no, lo que hacen es bajarse, para no molestar lo menos posible, un píxel, un fichero que es un PNG, que es de un píxel por un píxel, o sea, un cuadradito en blanco, con lo cual no va a distorsionar nada de lo que está usando el usuario y no molesta. Entonces el truco, la carne del experimento está en los URLs que vamos a utilizar para que el usuario vaya saltando por los obstáculos, ¿no? Esto igual no sé muy bien porque es pequeñito, pero estos son, por ejemplo, ejemplos de los experimentos, como los llamamos, que estamos corriendo, ¿vale? Creamos una serie de URLs específicos para cada usuario, de tal manera que sepamos a quién se lo hemos presentado y que tienen varias partes, y cada uno de estos va a hacer que sufran de una manera distinta. Esto es básicamente un UID para que sea único para cada usuario. Esto nos da información sobre en qué país está el usuario. Esto es un timestamp. Una de las cosas que hemos visto muy curiosas, se supone que cuando un usuario recibe esto y coge el JavaScript va a tardar unos pocos segundos en ejecutar el código. Sin embargo, si miramos los logs, vemos ecos a distintos tiempos, gracias al timestamp. Hay cosas interesantes, están los típicos servicios de seguridad que lo que hacen es capturan todo el tráfico que ven y luego hacen un replay unas horas más tarde para ver si el usuario, si detectan botnets y todo este tipo. Hay un browser chino que está basado en Gecko y tal, pero que una de las cosas que hace es que cualquier query que haga el usuario, 3 segundos después tú la ves, pero con origen en China. Da igual donde estuviera el usuario, alrededor de 3 segundos después esa misma query te vuelve a venir, pero con origen en China. O sea, todo lo que hagas con ese browser lo van a verificar porque se supone que es para protegerte. ¿Vale? Aquí lo que hacemos es codificar la dirección. Si el usuario ha venido a nosotros sobre versión 4, codificamos la dirección de versión 4 con la que ha aparecido para poder traquearlo cuando nos viene de vuelta en versión 6. ¿Vale? Y luego esto es simplemente el servidor y datos de control. La codificación es básicamente un test para usuarios que está disponible sobre el 4 y sobre el version 6, un dual stack básicamente, solo sobre el version 4, solo sobre el version 6. Esto lo que hacemos es conseguirlo. Corremos un servidor de nombres que hemos escrito nosotros, que lo que hace es básicamente mentir, ¿vale? Según lo que tú me preguntes, yo te voy a generar una respuesta en tiempo real, no está en zona, sino que simplemente te voy a devolver esto cambiado. Entonces te puedo responder que solo existe la dirección de versión 4 para este servicio, que solo existe la dirección 6, te doy las dos, y entonces con base a eso vas viendo si el usuario, si le das la dirección de versión 6 y no vuelves a saber nada de él, pues es que probablemente no puede hacer nada con el versión 6. Si les das las dos, entonces puedes medir cómo compiten los resultados en el browser, con todo el tema este de happy equals y tal, a cuál le dan preferencia y a cuál no. Y luego ya sigues con, por ejemplo, cosas como esta, DNSSEC, lo firmas con DNSSEC, lo firmas pero con una firma que está rota, inválida, es inválida a posta. Con lo que ¿qué haces? Distingues entre los usuarios que pueden acceder si les das datos de DNSSEC y distingues también los usuarios que realmente están validando esos datos. Porque esos, si les das una cosa que está firmada de forma válida van a poder seguir, pero si les das una cosa que está firmada de forma inválida se van a quedar por el camino. ¿Vale? Lo mismo con, si en vez de firmar con RSA, que es el tipo de claves que todo el mundo está usando hasta ahora, usas FDSA, que es el nuevo algoritmo, que por ejemplo es el algoritmo que usa Cloudflare para firmar todas sus zonas, porque la firma es mucho más pequeña y así te evitas problemas de tamaño de paquetes. Y luego ya tenemos una línea que es que se ejecuta al final, que es donde el browser nos va a decir a nosotros, desde su punto de vista, cuáles son los códigos, los experimentos que él ha conseguido ejecutar de forma con éxito. Una de las cosas curiosas es que a veces lo que te dice el browser que ha hecho y lo que nosotros vemos que ha hecho no es lo mismo, ¿vale? Muchas veces hay cosas que el browser cree que no ha hecho que sí que ha hecho. No se entiende muy bien por qué. Bueno, entonces, ¿qué vemos? Pues con los tests de version 4 versus version 6, por ejemplo, esto es la imagen que obtenemos a escala global, ¿no? ¿Cuál es el despliegue que utiliza? ¿Cuántos usuarios realmente tienen acceso y utilizan version 6 en el mundo en este momento, ¿vale? Una cosa es que la red tenga la posibilidad de transportar version 6 y otras que el usuario final luego lo haga. Por ejemplo, aquí en España el típico ejemplo, Rediris, la red académica, lleva dando servicio de version 6 desde ya, yo que sé, 15 o 20 años, una barbaridad de tiempo. O sea que si quieres, puedes tenerlo. Pero en las universidades a las que Rediris da servicio, casi nadie usa el version 6. O bien porque tiene equipos antiguos, o bien porque el equipo de comunicaciones de la propia universidad no les suministra auxilio a version 6, lo que sea, hay muchas reglas. Y esto lo puedes ir viendo, ¿vale? En España, por ejemplo, ahora mismo la utilización de version 6 está en el 0,3%, que es más bien bajita. Vamos a ver si puedo bajar aquí. ¿Dónde está el curso que no lo veo? Hola. Vale, esto es como se ve la utilización de version 6 a lo largo del tiempo en España. Parece que alguien está intentando hacer pruebas en los últimos meses.
Orange ha empezado a descontar.
Es muy poco, vamos, está pegado al cero. Esto es el mapa de la zona de básicamente. Si vais a la web está statslabs.net, os da un listado de los experimentos y podéis entrar y mirar en la zona del mundo. Mira, hoy ha cambiado desde que he cosa y hay un poquito más de version 6 en España. Esto está muy bien porque además como coincide con la bandera verde y roja. Pero vamos, veis que hay sitios donde la cosa está un poco mejor. Una de las cosas que hacemos también es presentar los resultados por número S en cada una de las zonas. Sabes, tú vas a ir cliqueando y navegando y ver cómo está tu AS. Hay gente que tiene version 6 realmente desplegado a fondo y lo está usando todos sus usuarios, pero lo que pasa es que son ISPs muy pequeños. Yecla es un pueblecito que está ahí en Murcia. Los tíos han hecho un buen trabajo. Lo que pasa es que bueno, están en una región muy pequeñita, ¿no? Y luego ya va bajando. Ninguno de los grandes, como veis, parece que estén por ahí. Uno que me gusta ver que está bastante arriba es Wi-Fi Net, que no solo da soporte en la red, sino que los usuarios parece que sí que lo usan, ¿sabes? O sea que eso está muy bien verlo. Y luego ya veis que por ejemplo, Redis aparece aquí, pero dentro de su red, y ya te digo, Redis lleva dando soporte de versión 6 en su red como 20 años, la población de gente que utiliza versión 6 está en el 4%, que es ridícula, vamos.
Hay muchas universidades que ni siquiera lo tienen desplegado.
Claro. Entonces, una cosa esa es la cuestión. O sea, una cosa es lo que intentábamos medir, una cosa es lo que la red puede hacer, pero otra cosa luego es lo que los usuarios van a hacer. ¿Vale? Está bien ver que lo de los happy eyeballs suele funcionar, excepto en casos como este, pero que en el caso de que les des versión 6 y el usuario lo vaya a usar, casi siempre lo prefieren. O sea, esta columna de aquí es, en el caso de que tienes los dos, ¿cuál de ellos va a usar el usuario? Y bueno, y aquí luego tenéis el modo de muestras para saber si la medida te da un resultado significativo o no, porque claro, no es lo mismo medir Telefónica que medir Yecla, ¿no? Por ejemplo, entre los ISPs grandes, el número de muestras es muy distinto. Esto es el número de muestras en cada día. Estamos sirviendo alrededor de 8 millones de anuncios cada día de distintos puntos, o sea que te da un muestreo bastante grande. Y ya veis que la utilización de los ISPs más grandes todavía es bastante pequeña. Tengo que esperar que se vaya desplegando. En las medidas, en la parte de NSSEC pasa otra vez lo mismo. Hay sitios del mundo donde realmente... Sí.
Antes de que pase a la del NSSEC,
dime.
Sacan una diferencia de B4 con B6 de tal manera que puedan hacer un mapa parecido a este, donde por ejemplo se ponga el rojo cuando el B6 es mucho más lento que el B4.
Sí, una de las gráficas, vaya, no tenía que haber recordado porque era, pero bueno, si tenemos unos minutos al final lo han visto. Hay una de las gráficas que publicamos es la diferencia en el RTT desde el punto de vista del usuario hasta nuestros servidores cuando usa B4 o usa B6. Si eso ahora vuelvo para no estar cambiando, ¿vale? El despliegue de NSSEC, por ejemplo, es bastante variable, no es muy alto, pero es en cualquier caso, al menos en este momento, un poco superior al de versión 6. Sí. Hay zonas donde realmente ha despegado. En Suecia, por ejemplo, no solo están firmados los dominios SE, lo que es el punto SE, sino también muchos dominios bajo ellos, tienen aproximadamente más de la mitad de los dominios firmados, sino que además todos los proveedores, todos los ISPs, están validando esa información, ¿vale? Y tampoco parece que se haya acabado el mundo, o sea que no está mal. O sea que esta gente y Estonia lo han hecho aposta y les funciona muy bien. Irlandia, lo que pasa es que Irlandia es un país pequeño. En Centro Europa hay gente que está haciéndolo, aunque todavía no son muchos, y luego hay casos curiosos, ¿no? Irak, por ejemplo, dices, joder, me parece que sea un sitio muy avanzado tecnológicamente. Y si os fijáis aquí, Corea del Norte. Curiosamente, mucha de la gente que valida, lo hace porque usa un servicio que todos estaréis bastante familiarizados. A ver si se ve aquí. Que es Google. Google habilitó la validación de DNS por defecto en todos sus servidores de DNS hace tiempo. Entonces tú ves que en los países donde hay mayor preponderancia de la que la gente configure Google DNS, el 8.8.8 como su servidor de DNS, la validación de DNS es más alta. Y eso es, por ejemplo, lo que pasa en cosas como Corea del Norte, que se supone que es una red que está restringida y controlada, sin embargo, mira, se les escapa todo por ahí. Bueno, ese es el tipo de visión. Otra cosa que obtenemos como dato colateral es el tamaño relativo de los usuarios en cada una de las redes. Así que nada de sorpresa, realmente. ChinaNet es el mayor ISP del mundo, con 300 millones de usuarios. Y luego varios de China, y ya vas bajando por los demás. Los países grandes tienen más datos. A ver si veo lo de Arturo. Vale, esta es la comparación de el RTT, el tiempo que tardan los paquetes en ir por cuando están usando versión 6 o versión 4. Y te marca las diferencias, ¿vale? Vamos a ver Estados Unidos, por ejemplo, que es un caso bastante curioso. ¿Vale? Cuando los números son negativos o verdes, quiere decir que versión 6 es más rápida. Que suele ser la norma. Sobre todo en los... Y eso pienso en los que están dando más atención al tema, como es el caso de Comcast, ¿vale? Aún así, todo el mundo tiene días malos. Por ejemplo, hoy Comcast tiene un 9% de fail rate sobre versión 6. Bueno, sorpresas las tenemos todos, ¿no? Como decía José, a veces la red te pasa malas jugadas. En nuestro caso, en el caso de España no tiene mucho sentido ahora mismo ver esta gráfica, porque hay tan poco cantidad de accesos que los datos son más ruido que señal, digamos, ¿no? Pero si lo vais a empezar a desplegar, buscad vuestra S y comparad como herramienta de diagnóstico. Esto se va actualizando mediante todos los días, o sea que ahí está para el que lo quiera usar. Y ya para acabar, tenía una cosa más. Vale, quería hablar de este tema. Es un estudio que hemos hecho sobre problemas de fragmentación en las redes, ¿vale? Todo el mundo da por hecho que tienes un MTU de 1500, que es el estándar de Ethernet, y que si pasas paquetes de 1500 no vas a tener nunca ningún problema. Mentira cochina. Entonces hemos medido, y estos son los porcentajes, a distintos tamaños de paquetes. Una de las cosas que podemos hacer con el servidor de DNS es meter información adicional para crear paquetes del tamaño que queremos. Entonces, con distintos tamaños de paquetes, esto es sobre transporte de versión 6, también se puede hacer con transporte de versión 4. Hemos estado midiendo cuál es el ratio de problemas para cada tamaño de paquete. Esto es sobre UDP y en versión 6. En versión 6, como sabéis, al contrario que en versión 4, no puede estar fragmentado más que por el origen, ¿vale? En versión 4, si tú mandas un paquete muy grande y hay un enlace en la ruta que no permite pasar, el router es encargado de fragmentar, pero en versión 6 no. Lo que tiene que hacer el versión 6 es el primer enlace, el que no deja pasar ese tamaño de trama, tiene que decirle al origen que no puede pasarlo, y el origen tiene que bajar el tamaño de la trama para luego pasar toda la red de una atacada, ¿no? ¿Qué pasa? Que esos son mensajes de ICMP de versión 6. ¿Qué pasa con los mensajes de ICMP? Que, por ejemplo, la gente parece que le tiene alergia. O sea, es el mecanismo de señalización que tiene la red para decir qué es lo que está pasando, y sin embargo hay mucha gente que decide que los filtra. ¿Sabes? Desde los tiempos de los ataques de Smurfs, esos de los pings, parece que aquellos, como lo peor que te puede pasar es que te llegue un ICMP. ¿Vale? Hay ocasiones en las que la gente abusa eso, pero es que es la información que te está dando la red para poder operar, ¿no? Entonces, es una cosa que nos preocupa, porque como veis, cuando el paquete pasa de 1500, estamos viendo un 23% de fallos. a finales de este año, en octubre, la zona de la raíz va a rotar las claves, ¿vale? Entonces, en cualquier rotación de claves de DNSSEC, hay un momento en que están la clave antigua y la clave nueva, porque siempre hay gente que va desincronizada, ¿vale? Con lo cual tus paquetes van a ser grandes, van a ser de este tamaño, de hecho. Da igual que estés validando o no, porque tu servidor DNS probablemente va a pedir toda la información de DNSSEC, por ejemplo Bind lo hace por defecto, entonces el paquete grande te va a llegar. Aunque luego no hagas nada con la información de DNSSEC. ¿Qué pasa si no eres capaz de recibir, como el 5% de la gente del mundo, qué pasa si no eres capaz de recibir la información de los root servers a partir de esa fecha? Porque vas a tener problemas de DNS en tu red, ¿sabes? Y te va a costar un rato saber por qué de repente ayer el DNS estaba funcionando y hoy no. Entonces, mirad vuestra red, aseguraros de que no te extrañas por ahí, o por lo menos que podéis pasar paquetes de este tamaño para evitar problemas. Llegue el 13 de octubre. El 13 de octubre es la fecha de rotación, creo que las dos claves se empiezan a anunciar a mediados de septiembre. Como esto se puede prevenir y se puede mirar la red a ver si hay algún problema o no, pues si queréis evitar que os suenen las alarmas llegada a la vuelta de las vacaciones de verano, lo podéis mirar antes. Otra de las cosas que queremos medir ahora, que estamos empezando a medir, es el despliegue del protocolo QUIC, que es el transporte este nuevo que está proponiendo Google, que está implementado en sus servicios y en Chrome como navegador. Lo tiene implementado ahora mismo tanto Google en sus servidores de web como Akamai en su plataforma de entrega de contenidos. Hubo un tutorial de QUIC en el IETF hace ahora 2 semanas y Google decía que básicamente el 35% del tráfico que les llega a ellos ahora mismo ya es sobre transporte QUIC, que eso equivalía a un 7% del tráfico que ve la red a nivel mundial. Bueno, pues queremos medirlo, a ver qué tal. Como además QUIC es un protocolo que está hecho para ir evolucionando, pues queremos ver cómo va el ratio de adopción de las cosas a la vez. Es un protocolo que está muy bien y una de las lecciones que creo que enseña a todo el mundo es el beneficio de hacer protocolos que se puedan implementar por desarrollos en user space en vez de en el kernel, ¿no? Todo lo que involucra el sistema operativo tarda años en desplegarse y sin embargo si puedes hacer una implementación en la aplicación del usuario, de repente todo el mundo pasa a usarlo. Y eso es todo, solo quería daros un poquito una idea de cómo funciona la cosa y de lo que se puede medir sin molestar a los usuarios. Ya está. ¿Preguntas?
Para el tema de QUIC que mencionas, para el Chrome hay un chisme, una herramienta, no me acuerdo ahora cómo se llama, lo puedo buscar, que te sale un rayito y te dice si está en HTTP2, en el SPDY antiguo o en el QUIC. No sé si lo tienes instalado, igual se lo puedes enseñar. En Chrome.
Net Internal.
No. Es un propio rayito.
Ay, por Dios, no puedo creer.
No me acuerdo cómo se llama, pero vamos, yo lo tengo instalado en el mío. Me parece que se llama Speedy, de hecho.
No,
es
pero
una extensión que se llama Speedy y te muestra QUIC también.
Sí, pero si haces el Netgear Internal barra...
Sí, pero yo me refiero, para verlo rápido en la barra,
Sí.
te sale aquí un rayito y cuando te posas sobre el rayito te dice si estás utilizando HTTP2, uno u otro.
Ya, eso no lo uso. Lo que uso a veces es ver esto, ¿ves?
Sí, correcto.
Sí, pero es eso mismo. El rayo este te lleva aquí.
Claro.
Yo lo tengo aquí.
Y luego, lo que decías del filtrado de MTU, simplemente recordar a la gente que si realmente quieren filtrar, en el caso de IPv6, ping, pueden filtrar echo reply, pero no ICMP completo.
Claro.
Que es una opción.
Claro. En el caso de versión 6, pero también pasa en versión 4.
Sí,
la gente que tiene pánico al ICMP también en versión 4, no se sabe muy por qué. La cuestión es que, más o menos, el TCP consigue recuperarse. Porque lo que hace es bajar el tamaño del trama y ya está, tirado para adelante, ¿no? Pero UDP no, porque no hay esa señalización de sesión, no existe sesión. Pero es que todo el DNS va por UDP. Y si el DNS no funciona, todo lo demás, te puedes ir a casa y dejarlo. ¿Vale?
No te muevas. Bueno,
Las estadísticas estas de el 5% de las peticiones fallidas, tiene que ser una tabla con AS de alguna manera.
Sí, todas estas están en lo mismo, bueno, están allí, a ver. No está linkeado, vale, te mando el link después a la lista. No está ahí linkeado. Si lo encuentro mando el link después.
¿Más?
¿Cuánto cuesta hacer esto?
¿Cuánto cuesta?
Sí, porque tienes que pagar a Google los anuncios. ¿Cuánto, más o menos, para hacernos una idea con los datos que vemos, cuánto costaría?
Estamos gastando alrededor de $1000 y pico al mes. Son... Ten en cuenta que Google te cobra por dos cosas. Te cobra por cada paquete de 1000 anuncios, o 1000 o 1 millón, no me acuerdo. Te cobra un céntimo o algo así, por enseñarlo. Donde saca el dinero si alguien hace clic. ¿Vale? Porque ahí entras en subasta contra otros. Y el que pague más es el que se lleva la gata al agua, digamos. El anuncio se vuelve. Nosotros hacemos anuncios para que la gente no clique. Intentamos que el anuncio sea lo más tonto y aburrido posible y que la gente lo vea y diga,
Es un píxel, ¿no?
Esto que lo vamos a quitarlo de aquí y seguir con lo que estaba haciendo.
Si no buscas el píxel en la pantalla no le puedes clicar.
¿Vale? De hecho, muchas de las campañas de anuncios que tenemos tienen un budget que creo que anda por $1 por día. Y eso nos da alrededor de 1 millón de impresiones. Son tramos de 4 horas. Porque eso es otro problema. El algoritmo de Google es muy listo y tiene un objetivo claro, que es gastar todo el dinero que le han dicho que puedes pagar. ¿Vale? Entonces, tú lo ves, tú arrancas una campaña y entonces el primer día lo que haces es, en los primeros 5 minutos ha gastado todo el dinero. ¿Vale? Y entonces luego ya aprende. Entonces, lo va bajando y va intentando que sea un ratio más, pero se da cuenta a lo mejor de que se ha pasado, de que lo ha bajado mucho y que al final del periodo, nosotros dividimos los anuncios en periodos de 4 horas que se van solapando para tener un poquito de control sobre la distribución horaria, que te queda dinero. Entonces de repente ves, al final, o sea, de dejar dinero sin gastar, no baja. Y entonces le cuesta alrededor de 2 o 3 días en estabilizarse, en aprender cómo gastar tu dinero de una forma lo más suave posible, digamos. Pero como esto lo tenemos corriendo básicamente siempre, pues la verdad es que $1500 al mes no es mucho. Para toda la información que puedes conseguir, está tirado. Y bueno, de vez en cuando alguien sí cliquea, pues no sé lo que luego harán con la página que sacan, pero bueno, ahí está. Es una forma muy barata de instrumentar la red.
¿Más preguntas? ¿Cuestión? ¿Comentarios? ¿Insultos?
Que vamos a cerrar con esto y un bizcocho y luego el que dice, se acabó el ESNOG de esta vez. Sí que quería decir un par de cosas. Uno, de nuevo agradecer a toda la gente que nos ha apoyado para el ESNOG, en particular al CSUB Catnix por alojarnos aquí y por, que nos han dado un montón de apoyo con todo el tema de audio-vídeo, de la wifi y todo esto. María Isabel en especial, que hoy no ha podido estar aquí porque tiene problemas de salud con sus padres, dedica un montón de tiempo a toda la gente del ESNOG y todo esto. Y luego también el Hispanix, que bueno, nos sigue dando los coffee breaks, la comida durante todos estos años. Y a F5 por darnos la cena de ayer, que creo que estuvo bastante bien. No sé cuántos de vosotros fuisteis, pero creo que nos pusimos ciegos ahí. Un tema que hemos visto que a lo mejor la gente se está confundiendo es el tema de las suscripciones a la lista de correo. La web, que necesita evidentes mejoras, tiene una cosa que es la que parece ser que todo el mundo usa, que pone suscripciones. Esas suscripciones que están puestas, las que se ven bien, en realidad no son suscripciones a la lista de correo, son a las actualizaciones de la web, del WordPress. Entonces, lo que vamos a hacer es coger a todo el mundo que se ha estado, se ha estado suscribiendo a la web, los vamos a poner en la lista de correo, vamos a mandar un mail fuera y el que no quiera, el que realmente solo quiera estar en la web, que se borre. El próximo SNOG vamos a intentar hacerlo en octubre en Madrid, pero todavía no tenemos del todo cerrado ni la fecha ni el sitio. ¿Vale? O sea que mandamos un mail intentando mandarlo lo antes posible para que...
Bloqueas vuestra agenda todo el mes y ya...
En octubre.
Ya hacemos un cambio del mes.
No, así, un tema... También, sobre todo para los que están en remoto, lo de que la gente se apunta cuando lo va a ver en remoto.
Sí, bueno, tenemos que cambiar algunas cosas del registro. Por ejemplo, hay mucha gente que se apunta pero en realidad no tiene intención de estar en la sala, sino que lo va a ver en remoto. Eso está bien saberlo. Las dos cosas, saber el número total y saber el número de gente que va a estar en la sala. Esta vez había 96 apuntados
Y por
y
suerte
hemos
no
estado
pedido.
sudando a ver si nos arriesgábamos o no, a ver si cabía todo el mundo aquí. Al final sí cabe, porque bueno, siempre hay gente que no viene, gente que solo viene uno de los días y tal. Esas son cosas que tenemos que mejorar por nuestra parte. Ha mandado Íñigo a la lista unas pequeñas enlaces a unas encuestas. Parece una tontería, pero eso nos ayuda un montón. Por ejemplo, saber cosas como si os parece bien que juntemos un SNOG a otro evento que vaya a ocurrir ya en esas fechas que sepamos de antemano, o no, os lo da igual, ¿sabes? Por ejemplo, esta vez empezando el domingo hay una reunión de los puntos neutros de Europa aquí en Barcelona, que también organiza el CATNI, con TESU, casi ni cómo tengo que decirlo. Y eso nos ha permitido, por ejemplo, traer aquí a Arnold Nipper y que presentara lo del peering DB, aprovechando que ya está de paso, ¿no? Entonces tiene sus ventajas, a veces tiene sus inconvenientes. Saber qué pensáis de eso nos vendría bastante bien, ¿vale? O sea que, nada más, muchas gracias, nos vemos en la próxima.